In this video, we're going to talk about CNC programming. First, I'm going to go through a lecture that goes over some of the basics, and then we're going to do a demo or a couple of demos with the routed mini part, as well as an example that goes over the CNC mill part from my assembly. Okay. All right, let's get right to it. So what is CNC? CNC stands for computer numeric control. Okay. And you doing it with CNC allows you to have more repeatability. It isn't necessarily more accurate, but it is repeatably more accurate and usually much faster. Okay. So usually when you make your CAM program, you make your G code. You don't do it by hand, although some people do. For us, however, we're going to be making this code with a CAM software. Okay, and that stands for computer aided machining. Okay, so yeah, we'll create the G code. What is G code, you might ask? Funny enough, when I was in undergrad, I had some buddies that tried to convince me it was the code of the streets, which is definitely not the case. Okay, but basically, it is the path that explains to the machine where to move in order to cut out your part. Okay, so yeah, we use Mastercam, Fusion, or HSMWorks usually to create a toolpath. We're going to be dealing with HSMWorks primarily, although HSMWorks is almost exactly the same as Fusion. So once you learn HSMWorks, you should be able to do it in Fusion as well. So going over some of the basics of G code, you have your G00, G01, G02, and G03. Okay, so a G00 is a rapid movement, so that's when it sort of jogs around quickly to move itself from one area to the other. A G00 is never used to cut, or it should never be used to cut, because the G00 goes at like basically the full speed that the machine can handle. Okay, a G01 is a normal speed linear movement. So it's a straight line and it can be X, Y, or Z. So it can be a diagonal and it can move in the X, Y, and Z directions all simultaneously or individually if needed. Okay, and then you have G02s and G03s, and these are circular paths. Okay, and again, you're given where the arc goes from and to in your X, Y, and Z, and you're also given an I and J. Okay, and the I and J gives you the XY displacement the XY displacement of the center point of the arc from your initial starting point. Okay, so yeah, it also has X, Y, and Z, but it also gives you the center point of the arc. Some other G codes. So you have your G10s, which are sort of your work offset planes. Okay, G20s specify your units. Some G30s are for threading. G40s are for your tool offsets usually. Although on the Haas machine, it usually calls it out in an H offset for your particular tool height. Your G50s are your work coordinate systems. Okay, so we'll talk a little bit more about what those are going to mean, later on when we do when I do the demonstration part of this. But yeah, those basically show where our XYZ origin is that we correspond with the cam and the actual part. Okay. You have your G60s, which are coordinate system rotation. So if you need to perform a rotation or an operation, you have G70s, which are a lot of turning and facing. So this is all stuff you would do on the lathe. You would normally not see any G70s for turning and facing on the mill, but some G70s are used for fine boring operations on the mill. Okay. And then your G80s are your canned drill cycles. Okay. So those can be kind of handy. You could say a G80, you could call it a G80 and then just give a bunch of specified locations and it'll take the drill and drill it in several locations. And you don't need to specify how high up or down you need to go because that will be kind of all built into your G80s. Okay. So yeah, those are some of the basics. I don't have every single one of these memorized, but it is important that you generally understand what certain G codes do, or at least know how to look them up so that you could see if you have any problem with your G code, you could sort of go in and investigate what it's actually doing. Okay. So again, We're not going to do things by hand mostly, but I can show you, basically this is the code, okay, that is spat out from when we make it on a CAM program, okay? And again, you could use HSMWorks, Mastercam Fusion, and so many others. I think RhinoCam is what they primarily use over at Tyler. Um, but yeah, basically what it looks like in the CAM model is, you have a representation of your tool as well as the blue path that tool goes through. Okay, so the blue path here represents the center line of the tool on the very bottom, so like kind of at the bottom tip of the tool. All right, and it shows basically how it moves around. Your blue lines are going to be your G01 stuff, or basically your main cutting path, and your yellow lines here are going to be your jogging or your rapid movements, and your green lines are going to be how it leads into the part as it initiates the cut. Okay. So let's go over some of the general camming features that we have. As you can see here, I have a couple of paths, but um, we usually want to think in terms of roughing and finishing. Okay, so any surface that you want to machine, you should try and do a roughing pass and then a finishing pass. Okay, and that's really helpful, so that you could get a better finish and even achieve higher tolerancing potentially. So yeah, let's talk a little bit about that. You have adaptive clearing and you have pocket clearing. Adaptive clearing is when you want to clear external geometries, as you can see in the second picture there. The adaptive is sort of like on the top, doing the outside perimeter of that little cylinder that's sort of sticking out of the top. All right, and then in the left-hand side, you have a pocket clearing, which is sort of doing an internal geometry. It's kind of hard to tell from this picture, I guess, but those, sort of half circle grooves that I've cut that are sort of black where the blue line is, obviously, those are some like kind of internal pocket geometries where I would, want to use a pocket clearing. Okay, and these are kind of intuitive. You basically can click various surfaces, and it will sort of figure out what it thinks you want it to do, and it usually does a pretty good job with like sort of minimal effort in terms of telling it exactly what to do. Next, so you have contours. Okay, so you have 2D contours and 3D contours. So I am using the same part here to sort of illustrate sort of different examples. But if you notice, we have the path on the left. That is a 3D contour. Okay, so that's done with a ball end mill. Okay, so believe it or not, even when the path is like all the way at its lowermost point, it's only ever going to be engaging on the little fillet that is on the top of the part right here where my mouse is. So the little fillet here is what is getting machined by this 3D contour that I have selected. Okay. And again, even though the path goes all the way down, it looks like to the surface of the material there, or this sort of flat surface of the material, the tool will only be engaging with that little fillet. Okay. And again, that's because it's on a ball mill, and it doesn't always engage right on the tip depending on how it's machining. Okay. And then if you compare that to the path on the right-hand side, that is a 2D contour. Okay, so 2D contour should be reserved for kind of vertical sides. So you see, in addition to the fillet geometry on the top, you have the vertical side walls on the sides of that cylinder. Okay, and again, you usually want to do a 2D contour for that sort of path. Okay, and that usually works good because you could build in finishing passes into the 2D contour where you can't necessarily do that with the 3D. But yeah, again, we'll go over that all with the demonstration. Okay, so we went over some roughing paths with the pocket and the adaptive clear. But now we could talk a little bit more, and the contour stuff was a lot of the finishing path stuff as well. But some more finishing path operations you could have can be sort of in the realm of facing or surface finishing. Okay, so let's talk a little bit about the difference. Okay, so you have horizontal, facing, and parallel operations that you can perform. Okay, so best way to describe it, if you have a horizontal, usually I reserve that for a planar surface that is flat or or has good parallelism with the XY plane of the machine. Okay, but the horizontal might have certain protruding elements. Okay, so if you look at the picture on the right-hand side, whoops, sorry. If you look at the picture on the right-hand side, you'll see it, when I click that top surface, it ignored or it knew how to deal with basically the little cylindrical piece that's sort of sticking out. Okay, so if I had so if I had like a more or less flat surface with like protruding elements, that's like a good application for a horizontal operation. Okay, if you look at a planar surface or even a non-planar surface, it could be curved as well. But a surface that is not parallel or yeah, it doesn't have parallelism with the X and Y axes of the machine, and or it can be curved as well. That's where you'll want to use a parallel. Okay, so you can see on this part here, there's like this little wedge that I needed to machine. Okay, and I used a ball end mill on that. Whenever a surface is not parallel with your XY plane of the machine, that's when you'll want to use a ball end mill, even if it doesn't have even if it's non-curved. Okay, so even if it is like flat, as long if it's not parallel with and your XY plane of the machine, then you'll need to use a ball end mill. Okay, but again, that's a finishing path that you might want to use. Okay, next we'll talk about facing. Okay, so facing, it doesn't necessarily know any of the protruding or cut geometry. All right, so as you can see with the disc here on the left-hand side, the path goes over the top of the material and it sort of ignores all of the cutouts and holes and geometry that I've put there. Okay, so sometimes when you first start out with a piece of material, you might want to face it down to a certain height, and then you might want to cut all those geometries into it. Okay, so facing is helpful if you want to get the entirety of a surface flat, maybe even before you do other machining operations. Okay, next, talk about turning and facing. Again, we're not going to really mess too much with the CNC lathe, okay? But this is what a path would look like. And really, a lot of times on a lathe, it's kind of even more simple. So there's threading paths, but generally, if you have like a cylindrical profile, you really only need to do a mill or a turn face operation, and it can both turn and face your part here. As you can see with this guy here, I have it doing a couple of roughing passes, and then it finally does one finish pass that hugs the material and goes all the way around the sides and everything. Okay. Now I talked a little bit during mill training about your feed and speeds. Okay. Now what you can do is you could actually look up certain feeds and speeds and calculate what your spindle speed and feed rate should be. Okay, so yeah, let's talk about speed and feed calculations for the mill. Okay, so you might want to look up a certain service feed range for desired tool and material. Okay, so in our case, aluminum, you could say that can be anywhere from 400 to 1,000 service feet per minute. Okay, and that's just according to a certain publication. Certain tools will also recommend a certain service feed. Okay. And if a manufacturer recommends a certain service feed, that's probably more reliable than what you might find online, especially if what you find online goes over a very large range, which is the case in this example. Okay. You'll also select a certain tool that you want. So again, tool and material combination will probably give you a certain service feed, service feed range. And again, usually your service feed is not necessarily dependent on the end mill size, but the end mill material. Okay. However, the feed per tooth is dependent on material of material that you're cutting, material of the tool, and the diameter of the tool. Okay, so you look up your recommended service feed, you look up your recommended feet per tooth, and those feed into later calculations. Okay, so first thing you normally want to calculate is your spindle speed. Okay, so again, you have your surface feet per minute times pi over 12 over 2 pi. Again, you're converting feet to inches sort of thing. And basically, you're able to it's able to spit out a surface feed. So your spindle speed is equal to surface feet per minute times 12 over pi over d, okay, or diameter of your tool. All right. So yeah, next, what you would find would be your feed rate. Okay, so again, this is dependent on your feet per tooth, which you've looked up. Okay, and also the number of flutes that are on that particular tool. All right. So again, your feed rate is your spindle speed, which you've calculated from before, times the given feed per tooth times the number of flutes. Okay, and that'll give you your feed rate in inches per minute. Okay. Now, it might be the case that you are only engaging a portion of the tool's diameter or radius at a time. Okay, so if I'm using the full diameter, that's when I want to keep to the feed rate that I calculated with the equation in step 5. Okay, but if I'm engaging less of the tool, then I can use this chart on the right-hand side here. Sorry, on the right-hand side over here, which allows me to figure out how much faster I could go depending on what percentage of the tool's diameter I'm actually using. Okay, so if I'm using only 5%, then I could really increase my feed rate, greater than what I would normally use. Okay, and then you select the depth of cut. Usually, this is less than half of its diameter. So, but normally I don't really go much more than 50 thousandths depth if I'm using the full diameter, if I'm engaging the full diameter as I cut. And again, certain tool manufacturers will give you a sort of chip load or material removed per a given amount of time. So you could use that value to tune the depth that you're cutting with your feed rate. So you could basically figure out the swept volume of your tool as it cuts to figure out how much depth you could actually afford to use with that particular tool with given specifications. Okay, so now that concludes our presentation portion, and I will go over to our examples. Okay, so sorry to be a little bit jumpy here. I guess you deserve a little bit of an explanation. So this is sort of a re-edit of a video that I had made about a year ago. Up until now, we were able to get HSM Works, which is a SolidWorks add-on, which was very helpful because as a university, or as a college, I guess I should say, we normally teach you guys to do things using SolidWorks in terms of like, your CAD modeling and everything like that. So yeah, basically we're having to adapt here a little bit. The interesting thing, HSM Works. So yeah, the previous version of this video I'll keep available on YouTube so you could see what I'm talking about here if this is the only version you're watching. But HSM Works was an add-on for SolidWorks, and it is really almost identical, bar like one or two minor like features, I would say, that are different from one to another. But HSM Works is made by your Autodesk, and obviously for Fusion is too. So they're literally the same people making just a slightly different package. But really, I would say 98% of all stuff is exactly the same, or at least too similar to consider it different. Okay. So what I'm going to do is I'm going to go over how to do all of the machining operations that I went over in HSM Works in for this particular part, and I will also do the CNC mill part as well. Okay. So what I'm going to do, first of all, you would usually start in design. You have to import this, so I guess I could quickly go over that as well. So if I go to upload, I can select files. All right, and if I go here to Machine Shop Lab, I can scroll down and I can find uh router. Where's my router mini part? Might need a time lapse here. Sorry, I think I went past it. CNC mini part for students. There we go. So we can open that. Okay. CNC mini part for students. So that's it shows you how it imports it. And then you could go upload. In which case you get it over here. Um, yeah, but obviously I made this new save. It's basically going to be the same thing here. We could go and show this one. Okay, cool. So we have this one. So this is CNC mini part for students here. Um yeah, so that's the one we just uploaded. So I basically did the same thing. We'll just work off of this one that I made. So that the CNC routing mini part underscore from HSM just because it has some reference things in case I forget anything as I'm talking to you. Okay. Um so yeah, so let's continue. So we got CNC router mini part um, from HSM. And again, let's go back over to our manufacturer. Again, we can see the initial setup I made here. So we're gonna recreate that, and I'll use that as my reference. Okay, so we're gonna go to setup. All right. Now, we have the ability here in the setup. We could do a number of things. It's slightly different from that of HSM Works. But basically, the we need to tell Fusion here where we want our work coordinate system to be. Okay, so for the router, we're going to stick it here in the lower left-hand corner. Okay, so for the router, we usually like to have you usually like to have that on the lower left-hand corner on the bottom of the stock. Okay. The reason why you want it on the bottom of the stock is because all parts that are routed on the router are going to, yeah, basically all the time sit directly on the spill board. Okay. So if you have a particular tool, for instance, the 1/4 inch single flute end mill, which we're going to use, um, we are going to you can use that tool with many different material types. Okay, so you could use it with aluminum. You could use it with I use it pretty often with wood or MDF. There are better ones for wood, but it works really good with MDF. It works really good with plastic. It works really good with aluminum, especially if you don't have the ability to use coolant. So for that reason, you could set a tool offset height and then you could keep that for as many jobs as that tool lasts for, which is really helpful. So that's why you put the coordinate system on the bottom. Okay, and I like for it to be um on the lower left-hand corner. And what I mean by lower left, you could see all of these arrows represent the positive direction of each axis. Okay, so if you look here, the part exists in the positive regime for X, Y, and Z axes. Okay, so that's what I mean by the lower left-hand corner. Okay, for the next part we do, we will change the position of the coordinate system um, on the part, and I'll explain why that is when we get to it. But this is why we want it on the lower left-hand corner for the router. Okay, so now we can see this is our setup here. This is where we could affect our setup. But yeah, basically, you could do the model orientation. If I wanted to, I could set up, different z-axis. So I could make this the z. Oh, sorry. I could change the coordinate system all around. Um, but again, I'm gonna select the point at this lower point there, and then we're gonna make the z-axis. So I'm going to select the z-axis going up. Um, there we go. And then we're also going to select the x-axis going this way. All right. And then it's going to have us reselect that point there. So this is also the correct orientation that we would want that. Okay. So now the next thing we're going to do, so if we scroll around, we can see it's made the box size. It's based it off of how I made it before. Okay. So if we go to stock here, we could go to relative box size. Okay, there's several options here. So you could relative box size that adds a little bit of stock to all the sides, or at least, yeah, the top and the two sides. but not the bottom. Okay. The reason why it doesn't add any bottom offset is because normally in an operation you don't have the ability to like machine from under the part. Okay, you could flip it around, but that necessarily requires a different setup. Okay, so you could add stocks to all the sides. It doesn't do the bottom as I've explained. Okay, we're gonna go with a fixed box size. Um, well, actually, yeah, we'll keep it with the relative box size. I like that. We don't really need any side offset stuff. But we can keep it there. But yeah, this should be what's needed. We definitely want to have some stock above so that certain operations will do what they need to do, or we could see what we need to see out of them. Basically, this part was purchased as 3/4 inch material. 3/4 inch material is usually actually ends up being 23 over 32 inches inches tall. I've made this part zero point 0.7. Okay, so adding a little bit of stock there will kind of more accurately show, as we do a simulation later on, what it's actually cutting. Okay. So yeah, we could worry about the post-processing stuff. We'll be able to change all this. Um, later on. But yeah, we'll stick with those operations. So we should be done with this setup. So we're gonna click OK. Okay. Now, the first thing we're gonna do, normally when you have like a part on the router, you save the outside contours for last. Okay, so the outside stuff we're gonna do towards the end or at the very end. Okay. This part doesn't have any holes that need to be drilled. Um, but yeah, if you have any holes that need to be drilled or bored, it's recommended that you do those first. We don't have any of those, so we're going to do first the internal cavity here. Okay. It should always come to mind whenever you're doing any sort of milling or turning operation, you should always think roughing and finishing. You should always do hit two surfaces at least once a or sorry, at least twice a piece with a roughing and finishing pass, if not multiple finishing passes, depending on what is needed. Okay, so for us, we're going to try and do one roughing operation and then a finishing operation for all surfaces and contours. Okay, so the first one we're going to do, yeah, we could choose to do a 2D or 3D contour. It'll probably do a pretty similar thing when it comes to roughing out this cavity. Okay, so let's just grab the 3D pocket clearing. Sorry, I should say, yeah, I could do either a 2D pocket or a 3D pocket, but we could choose the 3D pocket clearing. Um, yeah, so we could see here we have our the first tab over on this menu you see here shows us all of our tool preferences. Okay, so it's probably worth it to mention some of that. So if we go to select here, okay, we could see that like I made this single flute, all right, and we could edit the tool and I could show you sort of what I did with it. So you could name it different things like the single flute. What I did was I changed the number of flutes here, and I messed around with the lengths and stuff like that so that it would be more accurate to what we actually have, or at least, yeah, somewhat close. And yeah, you could change all the information here. And yeah, we're going to accept that one. That's the one we're going to choose. But just to show you some of the things, we could go up to the user libraries in the upper left-hand corner over here. And now we have like the whole entire suite of like the preset end mills, which are very, very useful. Okay. So if you wanted to select, be a little bit more selective in what you're looking at, you can, select, say, flat end mill like we're, using, and you could see the 1/4 inch flat end mill. And when I select that, you could see all the different cutting feeds and speeds for, different materials and different processes with different materials. So slotting, roughing, finishing for aluminum and all these other ones as well. Okay. Which is very helpful. And you have each one of those, you have all that for all these different tools. So that's very useful. Okay. So again, we'll go with our single flute. We'll actually go cancel and we'll just make sure that we keep our single flute selected. Okay. These are left from the last time I did this, but basically normally, the way my single flute is set up, I have it so that it's doing 60 inches a minute by default. The reason I do that is because that's like kind of
what I usually leave as my speed setting for aluminum. On the machine, I'll usually leave it a little bit lower and then ramp up. But for the MDF, I'll usually leave it at 100, and then if I want to, I can, on the router increase the speed manually, which I usually do. So yeah, I keep the cutting feed at 100 inches a minute. Lead ins and lead outs and transitions, I usually leave at 30 inches a minute, just because those are usually some harder radiuses or like it's turning around a harder radius, and so it's nice to go a little bit slower there. Yeah, we could leave coolant on here. Not really gonna make a difference. I could disable it if I really wanted to. Um, but on the router, we don't have any coolant. Well, we have a mister, but um, it's not we don't program it, and it doesn't, like, it's not filled up, and yeah, it's like kind of disconnected. So yeah, we can leave that disabled if we want. Next tab over. So this is a multi-axis tab, and since this is just like a three-axis program, we're just gonna leave it at, we're not gonna check off anything there. So now under geometry, instead of this machining boundary, we're gonna do silhouette. So I'm going to do silhouette. Oh, sorry, not silhouette. We're going to do selection, and we're going to select that bottom silhouette. So I'll go over all these bounding box. You could, like, give a boundary section to where you want to cut. Um, Silhouette, you kind of just leave it at that, and then it kind of figures out on its own what it thinks you want it to do. Which can be very helpful if you have like a lot of complicated geometries and stuff like that. Doing a silhouette is nice, but we're going to do selection because we really only want it to rough out the inside of the pocket here, and we'll do the roughing with some other operations so that I can show you what all those do. So I've selected that face, and that's good. Now I can do rest machining and avoiding machining, so I can basically ignore certain aspects with the avoid machines surfaces, which can be helpful if you want to save some time. We're not going to select any of that for this operation. Okay. Now your heights, this will come into play later on, but effectively you could tell it where you want to start and stop machining. Okay, so here we're gonna make it so that the boundary is on the bottom and on the top, and those exist right on the bottom of the stock and the top of the stock. As you can see, it goes from stock top. And that's going to be just fine for what we're doing now. We will end up changing it a bit for the some of the 3D contours that we do later. Okay. Now with these passes, so yeah, you could see I could change a number of things here. What we are going to change a couple of things. So we're going to change the maximum roughing step down. So instead of 0.025, we're going to do 0.25. That would be really, really large. That'd be way too large if you were doing any sort of metals. But for what we're doing now, that is perfectly fine. We're going to do MDF, which is quite a soft material. Okay. So if you remember, we could change the direction. It's not going to really change too much here. If basically if I look at my code and I see like a lot of yellow lines, which are rapids, usually the yellow lines will rapid back to a certain position so that it can make a conventional or climb mill cut. And so sometimes if you have both ways, it can save time if you don't care about your finish. We don't really care about our finish in this case, but we're going to keep it to climb. Which will be just fine for us. I'm also going to click off smoothing and feed optimization. So I'll like kind of most of the time check those off. It's usually helpful to have them. Sometimes it doesn't matter too much, but if you can see what smoothing does, it sort of simplifies your tool path, and it can make it a little bit less like kind of jerky even, I've found. But yeah, basically smoothing makes it so that it completes a path with less points, and so that there's like kind of less lines of code, which can be helpful. Your feed optimization is basically when you slow down before a corner. So basically, you're approaching a corner in a car. You don't want to continue with your same speed and just jerk it around the corner, because your car will likely step out of line or skid or lose traction, whatever you want to call it. It's not like your end mill will lose traction. It's not like you know, it's not like driving along, right? But it certainly does have momentum, and as you're going around a corner, it jerks itself around. On the router, it gets a little scary because you're basically stressing those gearboxes out, and it's a lot of mass that's moving around, not just the tool, right? It's the whole entire carriage that's moving around. So yeah, that's important to it's nice to keep your feed optimization on. And sometimes if you notice it's jerking around too much, you could you could decrease the speed here or increase your radiuses and things like that, or increase this feed reduction distance, various things like that. So you can see it stops a little bit before the other one in these two pictures. So um, that could be helpful. Go into the sixth tab over here. You could do your lead-ins and lead-outs. So yeah, but basically that's like kind of the most important here. Your lead-ins, lead-outs, your ramps are what are going to be changed the most of the time. Um, yeah, a lot of this your linking stuff, I sort of leave that as to sort of like what it is, but this effectively tells you how it goes from various paths. So like if it's doing one operation over here and then it decides to do another operation over there, you could do it the most conservative way, which is full retraction. So if there's any unanticipated geometries, let's say, it'll definitely avoid those. So like if you're using a fixture plate, right, and you have a bolt like on your part, you might want to do full retract so that it gets out of the way of that bolt that, the program may or may not know it's there. But if you're confident that you don't have any of that, you could do minimum retractions and stuff like that, and you could do the shortest path, which can help save time. But yeah, I almost always leave it always on full retract. For what we're doing at school here, we're really not making any money, if that makes sense. So usually it's nice to go with the conservative thing. You're not really buying a whole lot when it comes to saving time, because obviously, as a student, your time is not valuable. Sorry, just kidding. But yeah, it's you care less about saving time in that way. Okay, what I will do is I will take the helix off. Okay, helix is a nice way to lead into the material in the like kind of Z direction. Um, yeah, if you have metal, you'll almost always want to do a helix. It's going to be much easier on your tool, but it's not really needed for what we have. So we're just going to plunge down. I know for a fact my tool is going to be able to handle that. Sometimes I will put, instead of plunge, I'll put like a profile, so it'll ramp along the profile and things like that. So yeah, there are various ways to do that. But we're just going to go with plunge for this MDF piece. Okay, so let's see how this generates. All right. So if you take a look here, yeah, so it looks like it roughs out the bottom and all the middle, right? And then it does do a roughing pass along this edge here. And you can see I'm highlighting the top edge of my part, and you can see the roughing profile, or however you want to call it, like the cut for that roughing pass, goes all the way around that top surface, which is what we want. Okay. Now you might notice that there is a exclamation point on that toolpath. Okay. So I'll show you where that's coming from. Basically, if I go over here to the fifth tab over, and it talks about uh our multiple, or yeah, maximum roughing step down. So if I make that 0.02, like where it was at 0.025 before. So if I make it a shorter step, you can see that exclamation point has gone away. And it's basically just, yeah, trying to make us aware that we're going rather large with that step down. And yeah, it's, I guess, saying you might want to watch out for that. But we know better, and we know we're cutting MDF and we're going to be just fine. Okay. Um, so yeah, great. That's roughing out all of that. Now what I'm going to do is I'm going to finish this internal profile. So as I said before, when you think about roughing and finishing, I'm going to show you guys two different examples of how I can finish the inside surface here. Okay, so first example, we're going to grab a 3D horizontal. So if you go to this horizontal, so 3D horizontal is nice to use when you have like a cavity that has like things around the sides of it, and you want that bottom of that cavity to be like nice and flat. Okay, or like, yeah, planar with the like planes of the machine, if that makes sense. So this has parallelism with like the flat bottom with the spillboard, which is our XY plane, let's say. Okay, so yeah, think about that when you have horizontals. That's like internal surfaces maybe that are flat with the machine. Certain times when you have like a flat surface that's on the very top that doesn't have anything like around it, you might just use a 2D facing operation. But yeah, for this one, horizontal I think is going to be appropriate. For the first tab, we're going to leave everything the same as what we set before. Okay, and it should probably put that as preset. Not going to do any or multi-axis stuff. For the geometry, we're going to do a selection and we're going to select this bottom surface. You notice it does tool outside boundary for the default. Okay, and you can see sort of what this graphic is telling you, what it's doing there. So we'll see how that ends up, and it's actually going to be kind of nice for us because if I select this bottom surface, it'll also actually finish this top surface, which is preferred. Um, Go to the fourth tab over here. We're also not going to mess with this on this tab, but don't worry, I'll show you where it kind of comes into play later on. Okay, so with this one, we're going to not do multiple depths. We are going to do a little bit of stock to leave just radially, because again, I told you I want to do, yeah, let's make it 20,000.02, but we will not leave any on the axial. So axial is like up and down, and radial is like on the sides. So we're going to leave 0 on the axial, or sorry, yeah, on the axial stuff, and then we'll leave a little bit on the radial. We're going to do our smoothing and feed optimization, and we'll uncheck only inner corners. Okay. Um, yeah, so now we could look over to the fifth tab. All right. And again, we will take out our helix, make it a plunge, but we'll still keep our lead ins and lead outs, which is nice. And that should be about it. So let's check on how that does that. Okay, great. So it goes up and around the outside, and it finishes, um, or sorry, yeah, it finishes this top surface. It might go a little bit outside of what we need it to. But again, I'm okay with it, like not really. Yeah, so I guess the pocket, if we really wanted it to, could rough a little bit more. So we can make it do that if we want to. Obviously, it's not that much of it's not that much material to like be dealing with. Um, uh, I'm fine with going in one pass for that, but just for consistency's sake, let's see if we tool outside boundary for the pocket. Let's see how that goes. Okay, yeah. So yeah, that goes outside a little bit farther, I would say. So the horizontal still goes out a little bit farther than that, but critically, we're not going to be doing anything where we go on any part geometry in just a single pass. Okay. So what I could do even more is I could edit the additional offset. And I can make it, let's see if I just make it 0.1, it should go all the way to the outside. Yeah, there we go. So you can see that and that basically are giving us the same thing, right? But just the horizontal just goes to a slightly deeper depth. Okay. So great. So we've roughed out with the pocket. We're roughing out a little bit farther now because we did tool outside boundary. And with the horizontal here, we're also doing tool outside boundary. So it's going to finish all that on the top and finish the flat part in the bottom. Okay. Now we're going to use a 2D contour and we're going to finish the sides. Okay. It should be said I could just, unclick stock to leave and it would do the sides here, but I'm just trying to give you a couple examples on how you could finish internal stuff. So we're going to go to 2D contour here. Okay. Again, leaving the presets for what we had from before. Second tab over, not going to do anything. Third tab over, we're going to select the edge. Okay, so with 2D operations, usually you select an edge or sketch entity. With a 3D operation, usually select a surface, whether it be flat or curved. Okay, so we're going to select that edge. And as you can see, you get the red arrow, and that red arrow should be in the void space. If I right click that, I can flip directions, which makes it not in the void space, which is what we don't want. But just to show you, if it ever ends up at the wrong spot, you can flip directions, and that's good. Okay, so now heights. We're gonna leave all the heights right where they're at for this one. That's gonna be just fine. Um, and let's see. Yeah, that all looks fine. The top is up there. Okay, cool. So the passes here, we're not going to do anything fancy to the passes. Um, we're gonna, yeah, not going to do any ramping or anything like that. We're doing lead-ins and lead-outs, and and that's just it. So we're going to click OK. This is going to be a very simple path, as you can see, and it just basically goes to the bottom and cuts out the sides. Very simple. Okay. So next, what we can do is we can rough out the top part here with a 3D contour. Okay, so let's grab a 3D contour. So 3D contour. I could also do this with a clearing operation because I'm just roughing. But here we go. So we're gonna do 3D contour. Not gonna select multi-axis, we're gonna leave tool one all the same. Not going to do any multi-axis stuff. We're going to go to geometry here. Uh, and instead of silhouette, we're going to do selection. Okay. Sorry. Selection. There we go. We're going to select the four surfaces on the top there. Okay. And we're going to select contact point boundary. Okay. And then, sorry, this menu is becoming too big. It's floating off the page. Okay. Oh, sorry. That's why we're going to subtract the browser thingy that I accidentally opened up. Come on. Oh, extend for me. Sorry. Just making sure you guys can see all this. Anyways, third tab over. As I said, we are going to change this. Okay. But I want to generate the toolpath really quick first so that y'all can see sort of what's going on. Okay. Now with this contour, the maximum step down here, we're gonna set this to point 0.75. I really only wanted to do just a couple of heights here. Okay. And we're gonna do stock to leave. We're gonna do 0.02 on both of those sides. We're gonna do smoothing, feed optimization, unselect only inner corners. I really kind of don't like the way these menus make you constantly adjust things. It's kind of annoying in my opinion. But anyways, smoothing, feed optimization, it's all looking good. For all the linking stuff, um, what are we gonna do for this? So yeah, instead of ramp, we're just gonna do plunge. Whoa, that was weird. Everything disappeared there. And that should all be pretty good. So watch what this does. Okay, as you can see, the path goes all the way to the bottom of the part. Okay, now that's kind of redundant for like what we want to be doing. So we're actually going to do it a little bit differently. And as you can see, we're going to limit the height so that these only go down, as far as they need to go. Okay, so Um, let's go back and we'll edit that. Okay, so looking here, we could go to the contour, that most recent one. We're going to go edit it. Okay, and we are going to go to the third tab over, or sorry, fourth tab over and change our heights. So we're going to make the bottom from model bottom point 4. So if you look at that, it uh brings that plane about there. Okay. And that's important because with the ball end mill, we want it to like go a little bit past the bottom. Okay. So if you recall, I selected this contact only and contact point boundary. So come on, if I hover over them, it should show, yeah. So basically, when this is enabled, all right, it allows the end mill to go below the surface that is selected. Okay, so as you can see, we need to on the third tab here allow that. So with the second tab here, we're saying yeah, we want it to go below contact boundary. We want it to go contact point boundary. Okay, which means bringing the end mill slightly below our selected surface. Okay, but it won't do that if we put this bottom plane too high, right? It'll ignore machining going below that. Okay, so point 4 should be enough to like fully explain all that. In fact, let's go to point 3 0.35. Okay. And that's because the diameter of the end mill is 1/4 inch, and therefore the radius of the ball, when we go to use a ball eventually, it won't be on this path, but when we go to use the ball eventually, we want it to be going just slightly below where it should be. Okay. So great. So 0.35. That's good. Let's take a look. And yeah, let's just click OK and see where that ends up for us. Okay, cool. So you can see there it roughs out the top very effectively. Maybe goes a little bit too far and does a couple of passes that we'll be dealing with later on anyways, but that's a good roughing pass for that. Okay. So now what we're going to do is we're going to Control C, Control V. Sorry, you can't do that in Fusion. We're gonna right click copy, and then we're gonna right click the setup, and we're gonna paste. Okay, so you got and then it puts that contour at the bottom. So we're gonna right click, we're gonna edit that. Um, and instead of the 1/4 inch single flute, we're gonna grab the ball. Okay, and we'll make that tool number 2. I showed you already how to select tools. You could just go and select your ball end mill. Okay, we're gonna change the speeds and feeds. Did I already change one of the presets? No, I didn't. So we got to change the speeds and feeds. Just make sure. Come on. So 10,000. Okay. Cutting feed rate, we're gonna make that 100 as well. Okay, 100 or so. And then I like to make the lead-ins, as you know, a little bit slower. Or yeah, a lot slower. I'm gonna make them like 30 or so. Um, yeah, just because that's a little bit more conservative. Okay, ramp also 30, and then plunge I also leave kind of a lot slower. Another reason to leave plunge a lot slower is that's usually like the first, thing it does as it enters a material. And if you make that slow and you're watching, you can stop it in time before anything goes wrong. So that's a good reason to leave that pretty low. Okay. Second tab over, not doing anything. Third tab over, yeah, not doing anything either. The selections are still fine. Uh, fourth tab over with the heights, that's all still fine. Now with the passes, I'm going to change this to 0.03. Okay, you can choose to go however much you or little you want with that. The smaller that is, the more time your tool path will take to run, but the smoother that fillet will be. Okay, so we'll click OK on that, and as you can see, it's going a little bit below that geometry, and yeah, it'll finish that top part out. Okay. Now, what we're going to do next is we're going to rough and finish the outside geometry, kind of with like a two-step that I like to use. Okay, so when you're machining on the router, okay, you don't have a vise, rather obviously, and there's usually not a great way to fixture things down. You could do a number of things, right? So we use tape primarily, and you can tape things down. And it works pretty well most of the time. Sometimes with aluminum, you'll opt to have additional screws in the material, okay? And you might even make it so that the part is tabbed or, has connecting pieces to your bulk material. I'll talk a little bit about that later in the video. Um, but yeah, it's you want to make sure as you're cutting that for most of the operation, all the way until the end, it's like stays attached to the material in some way, whether that is by a tab or by a little bit of stock on the very bottom. Okay, so I'm going to show you guys what I normally do for a lot of router parts, and that's like a little two-step where I leave a little bit of stock and do a finish around the sides, and then I go down to final depth. Okay, so let's grab a 2D contour once more. Okay, I'm gonna instead of the ball, I'm gonna go back to the single flute flat. Uh, that one. So yeah, let's just change the cutting feed rate to 100. Okay, just to make things go a little faster, and we'll leave all the other ones the same. Okay. So yep, there's that. Second tab over, we're not doing anything. Yep, that's all just fine. Okay. Fourth tab over, we're again not going to do anything. That should all be, yeah, fine. We're gonna leave that right where it is. Okay. Um, so now we're gonna do with this one, we're gonna do multiple finishing passes. Okay. And we're gonna do uh roughing passes as well. Oh, sorry, not roughing passes. We're gonna do multiple depths, so multiple finishing passes, and we're also gonna check off multiple depths. Where are you? Multiple depths. Um Yeah, sorry, multiple depths is down here. Um, and oops, sorry. Let me just make this just a little smaller so that we can see everything in this menu. Okay, so checking off multiple depths. We're gonna make our roughing step down 0.25, like we've done in some previous operations. And then we're going to finish only at final depth. Okay. And up here we could see our finishing step over is 25 thou. That's going to be good. I will go less. You'll go less than that when you have like harder materials. You won't be able to take as big of a finishing pass. Okay. For this one, we are going to do stock to leave. Um, sorry, it extended the menu again on me. Let's try that again. Okay. So stock to leave, we're gonna do none radially. Okay, and then I'm gonna on the bottom, actually I'm gonna leave 0.05. Okay, and that's 50 thou. And that's like to me, that's like enough to like grab to hold the part as you finish it up. Okay, again, stupid menu, making it smaller. Um, and then feed optimization. Come on. Making it smaller again. Feed optimization, we will uncheck only inner corners. Okay. And on the fourth one over, we will keep all of that the same. Okay. We're not going to ramp. A lot of times with 2D contours on an outside, I'll ramp it with like metals or aluminum, but we're not going to do that this time. Okay. So let's see. Sorry, one more thing. So I did stock to leave here. Okay. I could have, I guess, if I wanted to, instead of doing stock to leave, come on. I could have, if I wanted to, instead of doing stock to leave, I could have done, um, sorry, let me get this, detach that. I could have done the third tab over, I could have changed my bottom height. Okay, I could have changed that up 50 thou. Okay, so right now we're going to be machining on these side walls. So bringing that bottom up wouldn't do anything different than leaving stock. Okay, so let's pitch a scenario, right? And show you a little bit of the nuance between changing the bottom height and changing the stock to leave. Okay, so if I was making a pyramid, right, which has non-vertical sides, okay, and let's say I left stock, okay, everywhere around the pyramid, so on all surfaces of the pyramid, it would be a little bit taller than you would want it to be. Okay. If I instead of leaving stock just changed my bottom height on the pyramid, it would cut everything all the way around on the pyramid, but just leave a little bit of the pyramid on the bottom. Okay. So that would be what like the changing the bottom height would do on the pyramid. Okay. But for us, since this is just a 2D operation, they both pretty much do the same thing. Okay. So I guess I could have, if I wanted to change the bottom height up 50 thou or stock to leave 50 thou, both of them basically do the same thing in a 2D case. But again, they do mean kind of different things in the 3D case as well. Okay, so let's click OK on that. Oh, sorry, I didn't select an edge. Sorry, let's go back there. I have to go back to that and edit it and actually select something to machine. Okay, so we're going to select the bottom edge here. Okay, and cool, it goes all the way around. You can see that blue line, it makes all the way around, and the arrow is on the outside. So let's click check. Okay, great. So it's done a couple of depths, and as you can see, it's leaving a bit of stock there. All right. Last thing we're going to do is we're going to copy, Control C, Control V. Oh, sorry. You can't Control C or Control V. You go copy, right click the setup, do paste. Okay. And you can see where did that go? Sorry. Let's right click that, copy, go to there, paste. Why is it not pasting? Oh, sorry. I just needed to scroll down. So let's delete the second one we made there. That was redundant. So sorry, we have these two paths. I just needed to scroll down. We have these two paths now, and obviously they're both the same. We're gonna right click edit the second one, and we're gonna change some things around. So we're gonna uncheck multiple finish passes, we're gonna uncheck multiple depths, and we're gonna uncheck stock to leave. Okay, and that should be all we really need. We're gonna click OK, and as you can see, it goes all the way to the bottom of that piece right there. Okay, so that's looking pretty good. Um, yeah, that looks pretty favorable to me. Um, just taking a look at everything, it looks great. Okay. Um, so awesome. So that should be the whole path. Um, in the next part of the video, I'll go over an example for the CNC mill part.
In this portion of the video, we're going to go over how to machine the CNC mill part. Okay, so I give you another example of how to machine on the CNC router mini part, or yeah, I call it the CNC mini part. But we're going to tackle this one today. So the first thing I want to do is sort of identify the type of machining we want to do. So I've specifically made it so that this part would have like these inclusions or something quite similar on your version. But what I'm going to do here is prepare this to be machined with tabs. Okay, I'm going to show you a method of tabbing that I think is helpful because it's kind of really specific and allows you to put tabs exactly where you need it. If you use Fusion, which is again very similar to HSM Works, but one of the really big things that it does differently is in HSM Works you cannot do tabs, within the machining portion, but in Fusion, it allows you to make tabs in machining. But now I can sort of place these tabs exactly where I want, and I can make them whatever shape I want. So I feel it's worthwhile to sort of show you how all that works. Okay, so what do I mean by tabbing? Basically, we're going to create a superstructure around the part and then connect that like kind of frame to the part itself with tabs. Okay. And it's going to allow the part to be held in there and allow us to do, all these outside contours without having to have multiple machining setups. Okay, so, let's say I got a piece of material that was exactly as wide as this part here. I could grab it on one side and mill this pocket, and then grab it from another side and mill this pocket and so on. But since I had it, if I had it in the vise, I would, whatever direction I had it in there, I would not be able to cut that the sort of the contour that like touches it. Okay. And we also want the tops and bottoms and all sides to be machined relatively well, additionally. Okay. So that's what we're gonna do. Okay. First thing we want to do, I'm going to go onto the bottom plane here and I'm going to create a sketch. Okay. So I've created a sketch on the bottom plane, and now what I'm going to do is do an offset entities. Okay. So now I'm thinking about my offset dimension, and the fact that I want a specific type or size of end mill to sort of fit in that channel. Okay. So I'm going to make it zero point 0.3. Why don't I just make it zero point 0.4? Yep, I could make that 0.4 wide, and as you can see, it's made it like a basically a box. Okay. That should be good enough for us. That'll be fine for what we wanted to do. And I guess if it was zero point 0.4, I could also use a 3/8 end mill if I wanted to. I wouldn't want to go too much bigger than this because I don't want to inadvertently cut into my part. Okay, so we'll click check on that. All right, great. So now I've created this square. Okay, and what I'm going to do next is I'm going to create another square that represents my stock contours, and we'll double check things and make sure that the inner square is dimensioned properly. Okay, so I'm going to do a center rectangle, And we're gonna try and make it, you know what I'm gonna do first? Instead of the center rectangle, we're just gonna do a center line. And I'm gonna grab the midpoint of the top line of this of the rectangle and go down to the bottom one, make sure we're nice and vertical. Cool. Now we'll have this fully defined sketch entity that has a center point. So we'll be able to use our center point rectangle from there. And let's make it as big as we need to. Okay, so now I bought material that is 4 inches wide. But it is like a certain length. So yeah, I'll do 4 inches. But it is rather long. So if I needed to, I could have it be a little bit longer than 4 inches on the other dimension, but the other one must be 4 inches. Looks like it's going to be fine being even a little bit less than 4 inches, but I'm gonna just make it an equal sided guy. There we go. And that should be good. Okay, so now we're going to create line geometry that's going to represent um what where our that's going to represent where our tabs are. Okay, so I'm going to go over here and I'm going to make some lines. Okay, so I want a tab. Yeah, I want a tab going from this corner out to there. Okay, so why have I chosen to go horizontal to that portion? Although I could have gone to, I could have gone vertical, to that other edge. The reason I'm going horizontal is because I don't want these tabs to be on any of the like interfacing surfaces. Okay, so I don't like, so for instance, the tab is going to be created off to this side, and it's largely going to not affect this bottom surface there, which is going to touch another part. Okay, so I want to make sure that the tabs stay well away from the surfaces that it's going to interact with. So I'm going to keep going and do two more tabs, one to this side, and I'm just gonna be lazy and not pick up my pencil and go over like that vertically, or sorry, horizontally, and I will delete that sketch entity I just made because I don't need it. Okay. Oh, shoot, made that one on the wrong side. Let's try that again. I guess we could go to the inner ones, but I feel like it's going to hold it a little bit more securely if we go to the outer edges. Okay, cool. So now, that is good. Okay, so we could change our offset dimension on the fly if we really wanted to, and that would, help things, or that would, that could shrink or enlarge the sort of inner square that we see there. But I think that's going to work just fine. All right, let's move my face here so that I can exit the sketch. So exiting the sketch. Now we're going to create a series of extrusions. So the first extrusion we're going to make is going to be a boss extrude. Okay, I'm going to make sure I do the correct boundary. We're going to flip it and we're going to make it 0.5, which is what the thickness of the material is. So I made it 0.5 there, and yep, we're flush with the top of the material. So that's good. Okay, so now clicking check on that. Annoyingly, I have to do it kind of separately. Let's show my sketch once more. It hides the sketch, as you, I'm sure, know after you've made something out of it. But now we're going to make thin features for those guys. So let's go ahead and do that. So we're going to go here. Let's click that. Okay, cool. It knows what we want to do already. And you'll see what happens here. But when you click all these guys here, which I'm going to do. Whoops, not that. Yeah, so you see how one of them goes underneath and the other one goes on top? Well, let's also change the direction. But yeah, one of them kind of, that looks like it's correct and that one doesn't. So you kind of have to annoyingly do this in two. So I could do these opposite ones. Yeah, those look fine. I'm gonna make it, I'm gonna only make it go up point. I could probably make it 1/8 of an inch, but I'll make it 1/4 of an inch, 0.25. And the thickness is 0.1. Yeah, I mean that should be just fine. That should be enough to hold it as it's being cut, especially if I have four of them. So clicking check on that one. Okay. Now what I'm going to do is do the other ones too. So here we go. We'll just do the same exact thing again. clicking that there and changing there and oh, gotta go back to that box and select the other one. There we go. And now I can flip the offset. There we go. And now they're both on the correct side that I want them to be. Okay. And we're going up 0.25 and the thickness of the thin feature is 0.1. So that's good. Awesome. So now we have all of our tabs. Okay. And that would actually be enough for us to machine, but what I want you to realize when you machine anything with an end mill, I guess more specifically, wire EDM is sort of a different story, although you run into internal radiuses there too. But anytime you cut like an internal corner, it will not be a 90-degree sharp corner like that. Okay, it'll always be rounded. So I like to accurately portray that if I can. So we're gonna go here and we're gonna go do that, and I'm gonna make this 0.125 because that's the end mill radius we plan to use, and I'm just gonna plop that at all of the radiuses that are going to be, milled. Okay, there we go. And outside radiuses, so like this one doesn't have to be rounded because an end mill can go around a corner and create a hard edge, but not an internal corner. Okay, I'm gonna do all these ones as well. I'm gonna speed this up in the video. I guess I'll have to learn how to use that
speed up tool. Okay, there we go. And one last one. Okay, does that look pretty good? Oh, missed one. There.
Okay, cool. So we have all our radiuses all done and dusted. Okay, cool. So now, okay, now we can start, we could actually start doing stuff.
All right, hello everyone. So yeah, again, this is part of the readaptation of the machining video for use with Fusion instead of HSMWorks. So as you can see with this part, I've made the modifications already in SolidWorks to add these tabs. I added those manually. I will be going over in this video how to do other tab settings, although I found that, or I think that doing it manually is kind of nice. It's maybe a couple extra steps. But I kind of like it because it really fully shows what it's going to look like when it's done. And I could really control the size and location of the tabs more precisely than the other tabbing methods that are available in Fusion. Okay, but also go over those so you can use it if you want. All right, so the first thing we're going to do is we will go to make a new setup, create, make a new setup, new setup here. There we go. So now what we're going to do is we will place the coordinate system over there. And X and Y is, yep, that looks just fine. So we're placing this right on the, let's do, instead of stock box size, we'll just do selected point. And we will select that point there so it goes right on our part. Okay. And we could say our stock here is a fixed box size. Yeah, with no additional stock. So it's 4x4 and one or half an inch tall. Okay. So so great. So we have that job, or sorry, the setup. So let's click OK on that. All right, so now after we've created the setup, let's go ahead and we'll make we'll do our 2D pocket first. Okay. In HSMWorks, it actually took me a lot more operations to rough and finish this. Well, I guess two more operations. They weren't difficult operations, but it's pretty nice that in Fusion you can do them all at the same time. So we're gonna go 2D pocket. And it's because we're doing internal geometry. Usually I like to go for pocket. Okay. So the tool we're going to use, so you could go to select. I have this pre-programmed. So if I go to user libraries, or really just I go to the Fusion library, this should be what you see. And if I go to the flat end mill, you could go to the 1/4 inch flat. You could select the default one. I'm going to hit cancel. And then you just got to make sure that you change your feeds and speeds on here. Okay. So I'm going to do 10,000 on the spindle, um, uh, uh, 60 on the cutting feed rate, which will give me about 650 service feet per minute. That's what I like to use with high-speed steel tools and aluminum. If you have carbide tools and you're using it on aluminum, you could probably go up to 1,000. For my cutting feed rate, I'm using 60 inches a minute, which gives me a feed per tooth of 3 thou. I could probably go a little bit higher than that if I were using carbide. But yeah, that's probably pretty appropriate settings. I'm also going to change the ramp. I'm going to increase that a little bit here because we will be helixing. And let's make that something like 30. Okay, yeah, 33 should be fine. Okay, and we'll leave our plunge very slow. All right. We'll leave our coolant to flood. We're not doing any multi-axis stuff. Now we're going to select our geometry. So we're going to select all of these internal edges on the bottom, and we're going to make sure our arrow is also within the void space. All right, so we're going to go around there doing all that. And now normally I tell you to try and select just like edges and 2D stuff for your 2D like operations, and this is a 2D pocket, but we're actually going to select these faces here. Okay. There we go. Okay, cool. Now we'll go over to passes. Okay, we're gonna go we're gonna modify the stock to leave. Okay, so well, let's start up at the top. So first we will do multiple depths. We're going to make it so that it goes 0.05 every time. We're going to do finish passes. I could probably leave the step over for the finish pass at 25 thou, but we're going to go to 20 thou. Yeah, I think that'd be maybe slightly better. I usually like to keep it within 20 thou. Okay, great. And then we could do smoothing, feed optimization, only inner corners. Okay. And then we will finish only at final depth as well. Okay. And that should be good for now. I will modify things a little bit. Yeah, so let's also take off the radial stock to leave and the axle stock to leave. But I will change those after I show you a couple things. Okay. So now let's go over to the fourth tab over the linking. Helix should be appropriate. That should be just fine. If I wanted to do it in the profile, I could also do that. Or zigzag is cool too. But as long as you're not doing the plunge or the pre-drill or the plunge outside of stock, any of those will probably work, but I'm just gonna keep mine on the Helix. Yeah, and we're not gonna do any pre-drill positions. So yeah, let's check on how that does initially. Okay, great. So it's doing a number of things pretty well. Okay, looks like it's looks like it's doing our finish pass. We could see on the bottom depth, there's that other line that kind of goes a little bit to the side of our roughing passes. Okay, so you see all those are the roughing depths, and then on the final one, it does an additional offset path that is the finish pass. Okay. So one thing about this, from experience with these, it's kind of nice to continue below the stock. Okay, so you can see I cannot see any of the path going below the bottom surface. Okay, so really what it kind of ends up doing is leaving like a little bit of like aluminum foil kind of thing on the bottom, which is easy to cut out, and really you could just take it off with like a burring tool. But if you wanted to, I could go down a little bit more. Now, I've tried this a couple of different ways in preparation for this. So let me show you a couple things. So if I go, instead of the selected contour, if I go from model bottom and I go minus 0.05, okay, you can see it moves that plane. So you see that blue plane or whatever color blue plane below the part is like that's 50 thou below. Okay. Now, if I click OK, it looks like it does that from the side, but what it ends up doing is cutting through the tabs, which to be honest, I don't really know why it does that, even though I only changed one thing. But right now, it looks like it's going through those tabs, which is not what we want. Okay. If that happens, then the part gets removed. Okay. So before it didn't do that, but for some somewhat inexplicable reason, if you change the height to go a little bit lower, it completely deletes that tab, which we don't want. So we're gonna do 0 from model bottom. Uh, yep, 0. And we could even do it from stock bottom. Okay. Yeah. So instead of changing that, I'm going to go down to my stock to leave, and instead of 0 on the axial, I'm actually going to put minus 0.05. Okay. So it'll hopefully go down a little farther. All right. So let's check on that. Click check on that and see how it goes. Okay. It's still doing that. So let's go to edit. And let's change this back to instead of stock bottom, from selected contours, and then we just won't select anything. And we'll see how that does. Yes. Okay, so that has done it for us. So going back to selected contours did it. So if you notice, it is gonna go through the tab a little bit, but you see where that like green starts and basically where it shows as like gray there, it'll actually cut through. So you could see that there are some path lines that do go through the tab, but only at the top. Okay. And since the tab is really not important for this, they're going to end up getting cut out anyways when you finish your part. That is okay. So we're going to have plenty enough tab to like grab onto it well, to hold the part in there. And really going over it, that's only 50 thou moving into it. So that should be just fine. Um, and we will look at the side view here. And that should also be fine as well. I probably don't need to go 50 thou. I probably can do 25 thou. But we should have a 0.75 inch depth of cut with our 1/4 inch end mill. So that all should be just fine. Okay, cool. So we've made that path that both roughs and finishes all the geometry. So now what we can do is do our engrave. So we're gonna go up here. We're gonna do 2D engrave. All right. And I will select our number 3 engrave tool. So I did some custom stuff for this, but if I go to select, I can grab from Fusion's library. I can go to the engrave chamfer tools. Okay, and I could grab any one of these. I think I grabbed one and then I changed some of the cutting geometry. Yeah, so you could grab that one because it comes to a dead point. Um, and then you could edit it. I think you right click and you could select and you could edit things so that you can change things around a little bit. So yeah, I could select that one if I wanted to, but I'm gonna go with my uh, uh, 1/4 inch chamfer. I think I could have used that 1/2 inch one as it was. It would be the same, even if I didn't use a 1/2 inch chamfer tool in real life. It's really only for engraving. It's really only dependent on the tool center. So you don't really need to be specific about what size tool you use because again, it all is based off of the center. Whereas like if you're using a flat end mill, you need to know your tool diameter because, yeah, it's not, really, the center doesn't, well, it does matter, but you need to know the tool offset because obviously it's thicker than just an infinitesimally small point on the chamfer tool. Okay. So yeah, 10,000 should be fine. 30 inches a minute. Maybe that's a little fast, but it also should be relatively fine. And we'll keep all the ramps pretty low as well. Yeah, maybe I'll just change this down to 20, and that way it'll populate 20 for all the other ones. That should be fine. Okay. Um, Second tab over should be fine. Next tab over, we're gonna go and we're gonna try to select the tops. Okay, and all of those geometries. All right, and there and there, and there. And keep going and selecting all of these. There we go. Cool. And yep, can't forget this guy. Selecting the tops. There we go. And the mouth as well. There we go. And there and there. And okay, so let's take a look. Yeah, that should all be good and should all be fine there. Okay, so let's see what that does. See how that figures it out. Sorry, gotta click OK. Okay, so yeah, it looks like honestly it's going a little bit deeper than I might like. Although it looks pretty good there. Um, but you could see on the poop emoji, I can't really see where a lot of that path is going. Okay. And that's because like it's a little bit too low. All right. So what I'm gonna do, since I know the depth here, I'll just show you the depth actually, because I forget. I think I made it like 50,000 or 20,000 is that depth. Okay, so let's go and make the bottom from the top height. Okay, we're gonna make it minus 50. Oh, 0.05, minus 50 thou. Okay, and it's not doing it at all. Oh, sorry, because I went positive 50 thou. Let's try that again. So heights minus 50 thou. That would help. Minus 50 thou. Okay. And there we go. I think it's still going a little deep. Let's try. And it hasn't really changed that one. So instead of, I guess it's 20 thou. So let's try that again. Let's go 0.02. Okay. There we go. So now we could actually see the path there. Can we see it there as well? Okay, yeah. It looks like it's not going to cut those out. Okay. So let's go back and we'll just leave it at the 50 thou mark for me. Because I like the way, or yeah, let's try 40 and see if it completely covers the poop emoji. Yeah, there we go. So it should do all of the stuff it needs to do. Um, Let's see. Yeah, that should be fine. And it shouldn't go too deep because again, I only have it going 50 thou. So that or yeah, 40 thou, so that should be just fine in terms of the cutter's abilities. Okay. So yeah, that's our engrave. Now what I'm gonna do is actually put the engrave above the 2D pocket. Because it'll be kind of maybe better to do that once, if it's still a solid chunk and uh, usually you do your engraving and your drilling maybe before you do your main geometry stuff because usually it takes less time and you could probably still save the part even if your engraving goes wrong. Whereas if your pocket goes wrong, you might not be able to save the part as easily. Okay. Um, so yeah, that is it for like the main setup. Now, what I am also going to show you is how to do it basically another way. All right. So with this one here, what I did was I imported just the part. So this is the part as it is like in my main assembly. Okay. And what I did first was I sketched on this top plane so I could go if I go into design, I could go and I can right click hopefully and I could sketch or yeah, I should be able to yeah, start a sketch on a plane, right? Um if I go to create sketch and then I create a sketch on that face. I think I did it on the top. Yeah. So I made a sketch on the top. I made this line basically that allowed me to center a square on on the surface here. Okay. And so that square basically represents our 4 inch by 4 inch piece of stock. Okay. And from there, I can make I can make our offset geometries and things like that. So going back to manufacture, we can go, so this is the old setup for my reference, but I could go to setup. All right. For milling, we are going to do the we're going to do select point. Okay. We're going to go to there. All right. Leaving stock on all sides is probably appropriate. Okay, so we're going to leave this as yeah, yeah, from preceding setup. So the way I had it was relative box size with like 40 thou on all sides, except for the bottom. Uh, yeah, basically that's probably, yeah, that's pretty typical. For something like this, you leave a little bit of stock so that it knows to go around all the geometries. Okay, so that's good. We're leaving a relative box size with offset, what did it say? Add stock to sides and top. Sides, top, and bottom, and I'm not doing anything off of the bottom, and I could also, yeah, I can make it 0 off of the top because really all we need are the side offsets. Okay. Yeah, once we have that set up with a little bit of extra stock, we can select our operation. I'm not going to go over doing the engrave again. That would be exactly the same. But instead of making our own tabs, we can get the contour to make tabs for us. So again, I have my tool one with a 2 flute half inch, or sorry, quarter inch. Okay. For geometry, I could very simply go to the bottom edge and it selects all the way around. And I'm also going to put tabs. Okay. So right now it puts tabs in for us. Okay. The tab locations, I wouldn't want the tabs here because again, these tabs up on top are going to interfere with my top geometry there. So you see how I have holes there? Basically something bolts to the top of this part. Okay, where those holes are. All right. And so I want it to be clean out of the CNC mill. These sides here are less important for me because they don't touch another part. Okay, so we could do number of tabs. So instead of 1, I could just quickly do 0. Okay, and then I could make I could make manual tabs all the way around. So I could put one there, put one there, all over the place. I could put them wherever I wanted. Now I don't really have good control over these. It's really annoying how I can't even really, unless maybe someone in the comments can help me, but I can't really even rotate this around so that it goes to the other side. Which is kind of annoying. And that's why I kind of like to do the manual tabs because you get a little bit more control over exactly where they go. But I would probably put them somewhere like that, I would guess, just so that it would leave these faces completely flush. Okay. So yeah, that's another way you could do it. If you take a look at what that does, obviously it's only going in one depth, but you could pretty clearly see what it's doing. It's going to leave those tabs. And then this will be attached to the rest of the stock. All right, so I guess we could show how it's going to look by more accurately representing the stock. So the way I have the stock now is all you really need to make the toolpath. But if you wanted to like look at how it would most represent the stock, so yeah, that's too big. Sorry, we could go 2 and maybe just 1. Yeah, there we go. So that stock that I just made here represents the stock a little bit better than what I did before. And obviously I can make it a little bit more accurate, but this should show you what you need to see. So we're going to quickly regenerate that. And let's show it to you. Great. So that's what it'll look like, and that's where it'll put the tabs if I were to do it in this method. It would be a little bit less time because it wouldn't be clearing quite so much, like it wouldn't clear any of those geometries. Well, and obviously this is going in one depth, but even if it were going multiple depths, it would probably save a little bit of time. But yeah, I kind of like that the tabs where they were in my model from before. So yeah, I would still continue to go with this one from before and just have it do the 2D Pocket that also finishes all that. Okay. So yeah, that should be pretty much it for this video. Thanks for watching.